Here we go. Can you see? Okay, great. Thank you. All right. So thank you. I'm very happy to be able to present the thinking in this proposal around the benefits, the broader benefits to society. As our colleagues have already mentioned, this is a very important aspect of these proposals, and I'd like to acknowledge my colleagues with whom this has been prepared. In order to benefit society, if we have this project happening, we have decided, we thought it would be best to first focus on capacity development. We want to benefit from all the international collaborations. We want to build bridges with industry and encourage multidisciplinary collaborations, because there are lots of different disciplines, as our colleague just mentioned, that are involved in the realization of this project. We also want to engage the broader society, but we want to engage it meaningfully, really in the process of science, and we want to care about life on Earth. So this is what I'm going to discuss a little bit today. And obviously we want to link these to the Sustainable Development Goals. We have one more decade to achieve them, and we want to demonstrate that this project really can have an impact. And so we've identified a few SDGs to which we think we can contribute with the societal benefits of this project. So let's start with the capacity development, how we can train young scientists and technicians. This is how this vision takes place. So obviously training young scientists and technicians is very important. We have different ways of doing that. We have postgraduate scholarship, so helping young people join the world of research and make their start their career through this program is very important. We're also thinking of having research schools which are intense research oriented, schools that enable a lot of also cross-pollination across partners. And I'd like to point out just here that we can use this also to empower second and third tier universities in all the BRICS countries. So we can really use this to empower the smaller universities to be part of this greater whole. We also will run big data workshops and hackathons. We have quite a bit of experience now where we've run workshops where we train people to do science the new way it's done, using big data, using new technologies and new techniques such as cloud computing, and be able to run these big data processing pipelines and understand them. But also hackathons, because big data and analytics is a skill set that is broader than just astronomy. Astronomy is leading the way by generating these massive data sets, whether it's in time domain or in imaging or in other combination in multi-wavelength astronomy. So the ability to handle big data, to ask the right questions and to get information out of big data is a skill that we have some experience developing in hackathons, which are intense 2 to 3 day challenges, team challenges, and they are very effective at developing those skills. Obviously, conference participation is very important. And the advantage of a lot of this being virtual is that we envisage virtual hubs. So virtual hubs would be these virtual spaces where researchers can both engage with industry. It can happen across languages. It can be, as I said, it can be, for example, in a country where we engage other universities in that country. We can, because they're virtual, they can live across time zones and they can accommodate different learning modes. And so our goal here for capacity development is really to develop state-of-the-art training and collaboration opportunities for students in the network. So we also want to develop leadership among these young scientists. We want them to become the leaders, right? This is very impactful if all the students that come through this project can then display leadership and lead both the science, but also have fruitful careers and uplift the communities around them. So to develop leadership opportunities for early career scientists, we plan to embed in these programs training in things like communications, outreach, but also teaching and speaking and media engagement, because those skills are, they can make a difference in a young scientist's career, not just for their own personal career, but also in terms of gaining support for the science, gaining buy-in for whether it's at a political level or whether it is engaging their schools in their region and things like that. So this skill set, we want well-rounded scientists who are able to display leadership qualities. And we think with this, that promoting scientific excellence coming from BRICS countries will transform the global community and reduce the inequalities that you can sometimes find in the world of science that sort of mirror certain inequalities that we find in the global order. And so we really want to strengthen the scientific independence of the global south and the BRICS nations, so that the BRICS nation can really be leaders, not just in the technology and the science, but also the people that come out of this program. So developing bridges with industry is also a very important aspect, because industry really also revolves around a lot of economic activity. So we want to create bridges with economically active elements of society. And so this project really has big data analytics abilities and tools that are attractive to industry. But the channels we have envisaged to fruitfully engage industry include internship opportunities for our young scientists, but also cross-disciplinary interventions, where a problem that is something that has something in common with a problem faced by, say, an industry can be solved together. Obviously, the tools and the skills that we develop, because the analytics, the ability to do big data analytics, whether it's, you know, rapid response or whether it's big data processing, those are very attractive to industry. So we can share those through openness, but also, as I just said, real-time big data streaming, you know, having the infrastructure and the ability to do that is very important for a number of industries. So we have a lot of possible interfaces here with industry, and obviously we see that as contributed to industry innovation infrastructure, partnerships for the goals, and I'll touch upon that again when we talk about life on Earth, good health and well-being. But we also want to engage society and public awareness and develop our communities using this project, right? So it's important to develop outreach resources, right? Multimedia, multi-language. We envisage both a top-down approach where we can produce things that are, you know, for the whole project, but at the same time a bottom-up approach, because it's very important to know what works locally. So the synergy of having a brand for this big project at the same time as having a bottom-up approach that makes it match the needs of each community is very important. Then we want to adopt what we call the Cascade outreach model. Again, let me come back to the leadership qualities. The Cascade outreach model is a model where we develop the ability to be role models and to be mentors at every level of scientist careers, with a focus on mentoring the step just before where you are, so that the mentorship gets multiplied across sort of career stages. And it has to be with role modeling. It has to do with relatability. So the role models are relatable, and it will create a sort of a set of ambassadors for the project. We also realize the importance of open science when it comes to public awareness and the development of communities. So this is about openness, sharing data and resources. And for that, for example, the Open Universe project, which is UN endorsed and has been brought in by a colleague in Brazil. And that, but also citizen science is critical here, where the citizens are, these are projects where citizens are empowered to take part in the scientific process, in the scientific discovery process directly. And the data will be there, and there will be probably more data than a community of astronomers can benefit from. So we see this as making, opening the data and enabling citizens to take part in the research, in the scientific process. So we get the most out of this data as well. And we also will seek to nurture scientific temper. So the scientific temper model comes from our colleagues in India. And the way we want to engage societies is to cultivate an appreciation for and an adoption for scientific thinking. I probably don't do credit to the scientific temper as it's been developed in India. It's very deep, but this is something that we're definitely adopting in this project. And we also have our colleagues from the Office of Astronomy for Development that have developed a model of local socioeconomic development around facilities, around telescopes. So this includes astrotourism and also ecotourism. Our colleagues have a lot of experience around the world developing this. So we really want to make sure that where there is a scientific facility, the local society and the local community develop socioeconomically while preserving the quality of the site for astronomy, which is a really interesting topic. So now let me come to caring for life on Earth. So we have the ability to process very big data. We have the ability to have warnings as time domain rapid response. And so this is very important for a number of things. Within astronomy, obviously near Earth objects can come and threaten our society. So it's a topic that's very relevant for society, and this network will be able to contribute to that. But also we've seen with the COVID-19 pandemic that the astronomy community can help. A lot of astronomers have actually contributed their data analysis skills to the research into COVID-19 as it happened. And then I'm also mentioning here disaster management, because when we have to have a rapid response and we need to understand what's going on, the ability when we have a lot of data to process it and to say visualize it and to understand it fast is very important. So through early warning systems, through data analytics skills, through data processing capacity, and again, through this interdisciplinarity, we see this project as being able to respond to the threats for humanity and be part of those very profound existential questions that, that nature throws at us. And so to summarize, I think what we really do, we have a big vision for the benefits to society in this project. We really aim to build leadership in infrastructure and comprehensive big data analytics. And then with that, we shall invest in systematic training, networking, including leadership skills development of young people in BRICS countries. And we plan dedicated engagement of stakeholders and communities that positions our science in the broadest possible development context. So we will take development challenges in each of these and take them on board and think, how can we contribute? So basically, we see our proposal as part of a greater good. Really, the whole is greater than the sum of the parts. And that's the vision that we have for the benefits of society. And this is my talk. Thank you.
Thank you very much, Carolina. It's a really interesting talk. Any questions? Okay, we have a question from Kurt. Kurt, you can switch on your sound.
Oh, okay, thank you. Hi, Carolina, can you hear me?
Yes, I can. How are you?
Hi, I'm good, thanks. Thanks for a lovely talk. I was just interested in your virtual hubs, if you could just maybe go a bit more into that, exactly what the idea, not the idea, but how it works and what it is really.
So we see the virtual hubs as a virtual space. So it's not a defined form, but a virtual space where it can take the form of well, imagine a collection of digital tools and virtual tools that you put together, communication tools, etc., where you can. It's like a virtual platform where you can engage with industry, but it's also, you can have lots of different ones. You can have several platforms. I'm thinking, you know, a lot of these of the BRICS countries are very large. And so in order for us to be able to, even on a national level in each BRICS nation, bring everybody on board in this project, we can go and build these virtual platforms. It can include, you know, Slack spaces, it can include mailing lists, it can include websites, it can include, you know, we take these digital tools, but we use them as rallying points in the virtual space for this project. So that's how we can connect with, say, smaller universities and bring them on board and say, hey, there's an opportunity here, there's a lot of data. Why don't you come and be part of this project, use this data, whether for teaching or for development of your young researchers, and see, you know, and see if we can bring people together. We are actually about to run next week a hackathon, fully virtual, on Zoom. So it's going to be very interesting to have a hackathon online, and we know we learn from these experiences, and we'll bring the best practices that we learn from these experiences into these virtual hubs.
Thank you very much, Carolina. We should move to the next talk. Next talk by Boris Schuster from Russia about input of the flagship project into the asteroid comet hazard. Thank you very much, Carolina.
Thank you.